This is SpaceTime Series 27, Episode 5, for broadcast on the 10th of January 2024. Coming up on SpaceTime, a Monstrous X5 class solar flare launched towards the Earth on New Year's Eve. The X-37 space shuttle launches aboard a Falcon Heavy on another top-secret mission. And Beijing launches its biggest ever rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Sun has celebrated the completion of Earth's latest orbit around it by blasting a spectacular X5 class solar flare, dwarfing even Sydney's New Year's Eve fireworks display. The gargantuan flare was the most powerful solar eruption in 6 years, with radiation from the blast reaching Earth 2 days later. Solar flares are powerful bursts of plasma and energy erupting from the Sun's surface. They're triggered by the snapping of twisting magnetic field lines reaching out into space in gigantic loops from below the solar surface through sunspots, regions which appear darker than the surrounding area because of their lower temperature caused by the magnetic field lines. The Sun isn't solid, but rather a gigantic ball of plasma with different latitudes rotating at different rates, and that can cause its magnetic field lines to twist and snap, triggering solar flares and coronal mass ejections. The magnetic field lines snap just like rubber bands, in the process flinging powerful waves of radiation and plasma that stream across space at high speeds. Solar flares are classified by their strength, ranging from the weakest B-class events through C, M, and finally the strongest group, which are known as X-class. Each step up in a letter classification involves a tenfold increase in energy. The classification scale is further divided into numbers from 1 to 9, 1 being the weakest in the class and 9 the strongest. Observations by NOAA, the United States National Oceanographic and Atmospheric Administration, show the X5 class flare released on New Year's Eve was accompanied by a coronal mass ejection or CME, as billions of tons of charged particles or plasma and magnetic field material was flung into space and towards the Earth. It hit the planet 2 days later, triggering a geomagnetic storm and polar cap absorption event which lasted several days, as protons accelerated by the flare slammed into the Earth's ionosphere and were then funneled along the planet's magnetic field lines towards the poles, where their ionizing effect caused spectacular auroral displays, the northern and southern lights, the aurora borealis and aurora australis. But these ones were powerful enough to also cause disruptions to communications networks. These space weather events, or geomagnetic storms, often impact radio communications and navigation systems. They can also affect spacecraft by damaging or even destroying delicate electronics or causing the Earth's atmosphere to expand and wobble like a jelly blubber. That increases atmospheric drag on spacecraft, resulting in faster orbital decay and forcing spacecraft to use more fuel in order to boost themselves back up into the correct orbits, in the process shortening their overall lifespans. The increased radiation is also harmful to astronauts in space and even people on high-altitude aircraft. And if the charged particles reach the Earth's surface, they can overload power lines, blowing transformers, and blacking out power grids. The New Year's Eve X5 class flare was triggered by active sunspot AR3536, which produced another strong flare just 4 days later. The later M4 class flare also hurtled a streamer of plasma into space. Scientists are now awaiting fresh images from chronographs aboard NASA's SOHO spacecraft in order to determine if the escaping streamer formed the core of another coronal mass ejection. We do know extreme ultraviolet radiation from this new flare ionized the top of Earth's atmosphere, causing another radio blackout, this time over Australia and the surrounding Pacific Ocean. Mariners and pilots would have noticed a loss of signal on some frequencies for about 30 minutes during the flare's peak. This latest activity follows last month's powerful X2.8 class solar flare, which erupted out of the unstable sunspot AR3514. In fact, 2023 witnessed the most powerful geomagnetic storms in 20 years, as well as a 20-year high in the number of sunspots observed in a single month. The Sun goes through a regular 11-year solar cycle, during which it gradually increases in activity and violence, culminating in solar maximum, or solar max, when the sun's magnetic poles flip polarity, with the sun's north pole becoming south and its south pole turning north. The current solar cycle, number 25, is predicted to reach solar max either later this year or early next. This report from NASA TV.
Enveloping our planet and protecting us from the fury of the sun is a giant bubble of magnetism called the magnetosphere. It deflects most of the solar material sweeping towards us from our star at 1 million miles per hour or more. Without the magnetosphere, the relentless action of these solar particles could strip the Earth of its protective layers, which shield us from the sun's ultraviolet radiation. It's clear that this magnetic bubble was key to helping Earth develop into a habitable planet. Compare Earth to Mars, a planet that lost its magnetosphere about 4.2 billion years ago. The solar wind is thought to have stripped away most of Mars's atmosphere, possibly after the red planet's magnetic field dissipated. This has left Mars as the stark, barren world we see today. By contrast, Earth's magnetosphere seems to have kept our atmosphere protected. Eftahia Zesta of the Geospace Physics Laboratory at NASA's Goddard Space Flight Center notes, if there were no magnetic field, we might have a very different atmosphere left, without life as we know it. Understanding our magnetosphere is a key element to helping scientists someday forecast space weather that can affect Earth's technology. Extreme space weather events can disrupt communications networks, GPS navigation, and electrical power grids. The magnetosphere is a permeable shield. The solar wind will periodically connect to the magnetosphere, forcing it to reconfigure. This can create a rift, allowing energy to pour into our safe haven. These rifts open and close many times daily, or even many times hourly. Most of them are small and short-lived. Others are vast and sustained. With the sun's magnetic field connecting to Earth's in this way, the fireworks start. Zesta says, the Earth's magnetosphere absorbs the incoming energy from the solar wind and explosively releases that energy in the form of geomagnetic storms and substorms. How does this happen? Magnetic lines of force converge and reconfigure, resulting in magnetic energy and charged particles flying off at intense speeds. Scientists have been trying to learn why this crisscrossing of magnetic field lines, called magnetic reconnection, triggers such a violent explosion, opening the rifts into the magnetosphere. NASA's Magnetospheric Multiscale Mission, or MMS, was launched in March 2015 to observe the electron physics of magnetic reconnection for the first time. Bristling with energetic particle detectors and magnetic sensors, the 4 MMS spacecraft flew in close formation to areas on the front side of the Earth's magnetosphere, where magnetic reconnection occurs. MMS has since been conducting a similar hunt in the magnetosphere's tail. MMS complements missions from NASA and partner agencies such as Themis, Cluster, and Geotail, contributing critical new details to the ongoing study of Earth's magnetosphere. Together, data from these investigations not only help unravel the fundamental physics of space, but also help improve space weather forecasting.
This is SpaceTime. Still to come, America's X-37B space shuttle launches on another clandestine mission, and Beijing launches its biggest rocket ever. All that and more still to come on SpaceTime. SpaceX has successfully launched the United States Space Force 52 mission, carrying an X-37B space shuttle orbital test vehicle on its 7th mission. The launch from Pad 39A at the Kennedy Space Center at Cape Canaveral Space Force Base in Florida was flown aboard a Falcon Heavy rocket, which uses 3 Falcon 9 core stages mounted side by side. The launch had originally been slated for December the 7th, but had been delayed by a combination of bad weather and ground support issues. It's the 3rd time the Falcon Heavy configuration had been utilized for a national security payload. But it's also the first time the X-37B had been launched aboard a Falcon Heavy, which is a payload capacity of 26,700 kilograms. Following the launch, the twin side boosters successfully returned to Earth, landing at SpaceX's landing zones 1 and 2 at Cape Canaveral. The core stage was expendable.
Falcon Heavy is in startup.
Great news. There's that call out. That Falcon Heavy is in startup. Now just waiting for the final call from the launch director.
This is the mission director. Go for launch.
And great news with that call out. All systems are go for launch of Falcon Heavy with USSF 52.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power and liftoff of Falcon Heavy. Go USSF 52.
MOD chamber pressure nominal.
Nominal power and telemetry.
At T plus 50 seconds into Falcon Heavy's flight, under the power of 5 million pounds of thrust, Falcon Heavy is carrying OTV-7 out to space. Now we are coming up on max Q here in a few seconds.
Max Q.
That is the point of peak mechanical stress on the vehicle, and we've now passed through that. So we do have a few events coming up here. That will be booster engine cutoff, or BECO, separation of the side boosters, followed by side booster boost back burn startup. That'll be the separation from the center core. The center core will continue to carry stage 2 with the payload until it shuts down its engines with MECO and performs a standard stage separation like you see on a Falcon 9.
Booster engine cutoff.
Side booster separation confirmed. Come back, Phil. Booster boost back startup.
BECO, the side boosters have separated from the center core, and we have the startup of the boost back burn on both of those side boosters. Now the side boosters are returning to Florida under the power of 3 engines. Coming up are a few events in rapid succession. That will be the conclusion of the side boosters boost back burn, MECO, stage separation of the center core and the second stage, as well as SES-1, or the NVAC engine igniting on the second stage. SES-1 stands for second stage engine startup. Per the request of our customer, we will not be showing second stage views after SES-1. Additionally, our center core, or stage 1, is expendable today, so we will not be attempting to recover it, but we will be following the side boosters back to land, so you can continue to stay tuned for that. We're coming up on the conclusion of the side boosters burn.
Booster boost back shutdown. Stage separation confirmed.
And back in mission and full power.
Callouts for the side boosters boost back burns concluding. We had MECO, or main engine cutoff of the center core, as well as stage separation, and also heard confirmation that the NVAC engine has ignited. Now, as we mentioned before,
Fairing separation confirmed.
Confirmation that the fairing has separated from the second stage. Again, we will be attempting to recover those fairing halves when they fall back to Earth using our recovery vessel, Doug.
Trajectory is nominal.
Now, again, as I mentioned earlier, the center core was not built to land or be reused. It is expendable, having given its all for the mission. For the 2 side boosters, the boost back burns have completed, and so far the vehicles are on a good trajectory coming back to land. And again, with successful second engine start 1, that will wrap up our coverage pertaining to the second stage. So we'll focus our attention on the side boosters. Now, those side boosters are currently on their way back to land. In order to land back on land, we typically have 3 burns.
Center core FTS has saved.
We typically have 3 burns. They've already concluded a boost back burn, which helps them turn back around and head back towards land. The next burn coming up is the entry burn. That's where we'll reignite 3 of the engines on each of those boosters, and that helps slow them down as they enter back into the Earth's atmosphere. Now, if we do have successful landings today, it will mark the 257th and 258th landing of an orbital-class rocket. And again, as I mentioned earlier, the center core will be expended, and we are not attempting to recover it today. Again, the entry burn is coming up here for the side boosters.
Booster entry burn startup.
And there's that call out that the entry burns have begun on the side boosters.
Stage 2 FTS has saved.
The engines have reignited.
Booster entry burn shutdown. PY FTS has saved.
And a short
NY
burn.
FTS has saved.
Short burn for both of those boosters, just under 20 seconds.
All vehicles are on nominal trajectories.
Great callouts there. All vehicles on nominal trajectories. Now, again, we do have 1 more burn for each of these side boosters coming up in just about 30 seconds. That is the landing burn. It's a single engine burn for each booster. and just one engine is powerful enough to slow the vehicles down and safely land back on land. Again, we are targeting landing zone 1 and landing zone 2 for today's landings.
Booster landing burn.
And we heard that call out. The engines have reignited.
Landing leg deploy.
The side boosters touch down for landing.
Stage 2 is in terminal guidance.
We hear the crowd here, very excited. We have successfully landed both Falcon Heavy side boosters on landing zone 1 and landing zone 2. With these two side boosters, this marks the 257th and 258th overall successful landing of an orbital-class rocket.
The flight was the 5th mission for the Falcon Heavy's current set of side boosters. The Pentagon has released little information about the Delta Wing spaceplane's latest flight, saying only that it would involve multiple cutting-edge experiments. The U.S. Department of the Air Force Rapid Capabilities Office says the tests included operating the reusable, autonomously controlled spaceplane in new orbital regimes, experimenting with future space domain awareness technologies, and investigating the effects of radiation on material supplied by NASA. The X-37 was originally designed as a NASA project. The spaceplane was designed to be launched into orbit inside the payload bays of NASA's Space Shuttle fleet and will then be released to undertake their own missions, including the deployment of satellites from their own payload bays, the rendezvous and repair or modification of satellites already in orbit, and the capturing of orbital satellites for return to Earth. However, following the 2003 Columbia disaster, the X-37 was modified for launch on Delta II rockets instead. The project was transferred from NASA to the US Air Force in 2004, and the project then became classified. We know the X-37 carried out a series of glide tests using Scaled Composites' winged White Knight mothership, and in 2006 the Air Force announced that it would proceed with a variant of the original NASA X-37 to be known as the X-37B. Because of concerns over the unshrouded spacecraft's aerodynamic properties during launch, the new X-37B variant was specifically designed to fit inside the payload fairings of the Atlas V rocket. Boeing built 2 of the spacecraft, designated as the X-37B Orbital Test Vehicles 1 and 2. One of the X-37B's most annoying features, at least from an enemy's point of view, is its ability to radically change in orbit. It can fly in a highly elongated orbit that dips down into the upper atmosphere, using its wings and atmospheric drag, as well as its maneuvering thrusters, to dramatically change its orbit so it doesn't fly on a predictive schedule. This annoying ability to seem to disappear means the Russian and Chinese can't track the spacecraft or guide their own satellites to get a closer look at what's going on up there. If they try, US mission managers simply change its orbit so nothing shows up where the enemy's expecting it to. This is SpaceTime. Still to come, Beijing launches its biggest rocket ever. And later in the science report, paleontologists have discovered what appears to be the oldest known photosynthetic organisms ever found deep in the outback of the Northern Territory. All that and more still to come on SpaceTime. China has set a new national space record, launching its biggest rocket ever. The 63.2-metre tall Long March 5 had been fitted with an extended 18.5-metre payload fairing. The flight from the Wenchang Satellite Launch Center in Hunan Province carried another Chinese Yaogan spy satellite. Beijing says the new extended fairing replaces the old 12.3-metre fairing usually fitted, enhancing the rocket's capabilities. Fairings are an essential component for any launch vehicle, as they house the satellites and other payloads, protecting them from the aerodynamic forces which hit a spacecraft during its launch into orbit. This is SpaceTime. And time now to take another look at some of the other stories making news in science this week with a science report. Paleontologists in the Northern Territory have just uncovered the oldest known photosynthetic organisms ever discovered. The 1.75 billion-year-old microscopic fossils, reported in the journal Nature, were found in the Northern Territory's McDermott Formation in the southern MacArthur Basin. The discovery is shedding new light on the origins of photosynthesis, the process used by plants and some bacteria known as cyanobacteria to convert water and carbon dioxide into glucose and oxygen using nothing but sunlight. The researchers found structures known as thylakoids, which are also found inside plant cells and modern cyanobacteria, inside tiny fossils called Navafusa. The discovery of thylakoids in a specimen of this age suggests that photosynthesis must have evolved sometime before 1.75 billion years ago. A new study warns that clocking up 6 or more hours of sedentary leisure time daily could double a woman's risk of uterine fibroids before she's gone through menopause. The study, reported in the British Medical Journal, was based on examinations involving some 6,623 women in China aged between 30 and 55. Uterine fibroids are growths in the uterus which can be benign but could also potentially become large, painful, and affect fertility. Participants were asked to specify how much time they spent on sedentary activities, such as board games, screen time, or knitting, and the authors found that the more sedentary time spent, the greater the risk of fibroids. While this kind of study can't prove cause and effect, the authors say there might be other associated explanations, such as the fact that an inactive lifestyle is related to obesity, which is also a risk factor for high estrogen levels and fibroids. Other risk factors include metabolic disorders, chronic inflammation, and vitamin D deficiency. Experts have traditionally thought that one big city park, like Central Park in New York for example, would support more biodiversity than several smaller parks adding up to the same area. However, a new study reported in the Journal of the Proceedings of the Royal Society B is challenging that idea, at least for birds. Scientists looked at the seasonal diversity of birds in 475 parks in 21 American cities, finding that groups of lots of small parks consistently had higher species richness and were inhabited with more rare species than areas that had fewer but larger parks of equivalent area. However, the authors found that larger parks did support other measures of bird biodiversity, and so the authors say both sizes seem to play an important role. They suggest urban planners consider the implications of park size on regional conservation goals. How Starlink will turn your cell phone into a sat phone, Microsoft's new AI key, and new Samsung Galaxy cell phones on their way later this month. With the details on all those stories and more, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
This month there were 21 Starlink satellites launched, and 6 of those have the capability to have direct-to-cell phone calls. And this is being done in conjunction with T-Mobile, one of the big providers in the US. So Elon Musk is calling this a cell phone tower in space. And this will work with an ordinary unmodified phone. They've got to be 4G LTE compatible, and that's obviously the vast majority of smartphones already on the network. And so there'll be a rollout of more of these over the next months and years. And there'll also be a text messaging service later this year, as well as access to data, which is also an important thing in the modern era. And of course, connections to all those IoT, Internet of Things devices, the little sensors and the various things people use on farms and all over the place to be able to connect those remote devices back to the network. So this means that eventually, unless you're deep in a cave somewhere, you will pretty much have connectivity everywhere. And a lot of the black spots as you're driving around Australia or in different parts of the world where there is no connectivity, as long as you have line of sight to the sky, you will have the ability to make and receive phone calls, data and text messages. And it's an augmentation of the capability that we saw with the iPhone 14 and 15 that could make emergency SOS calls. So this is just yet another evolution of the ubiquitous communications that we already enjoy.
So this means that in the future, in the not too distant future, things like Iridium, which provides satellite phone services, they'll become, I hate to say it, redundant, because you'll be able to use your own cell phone to achieve the same result.
Well, look, eventually. Clearly it will take time for more of these satellite cell phone versions to be launched into space. The existing ones can't do that. And you've also got Amazon launching a lot of satellites. So we're going to have competing networks that will offer this. Elon Musk says that this will eventually allow for mobile phone connectivity everywhere on Earth.
Another advance in artificial intelligence intelligence with Windows about to introduce a special button.
Yeah, it's called a new Copilot key for Windows 11 PC. So it's to the right of the space bar where you have an Alt key already, and to the right of that will be this key that has the Windows Copilot logo, sort of almost like an infinity symbol, but not quite. This is in addition to the Windows key that's on the left-hand side of your keyboard, if you have a Windows PC, that brings up the Start menu, and Microsoft launched that key nearly 3 decades ago. But a lot of the new Windows 11 PCs that will come with both AMD and Intel chips that have a built-in AI neural engine, much like your smartphone and tablet does, well, this key will bring up the Copilot, which is Microsoft's version of ChatGPT, powered by GPT-4, and it will enable you to quickly and easily get access to your digital smart assistant to do all the things that we currently do with AI, and hopefully over the next couple of years a whole lot more, as people really take advantage of the fact that PCs will now have this built-in AI engine, and you'll have a very easy way to access it. Press one key on the keyboard and off you go.
And Microsoft isn't just doing Copilot on PCs.
Yes, well, they've announced the Copilot app was available for Android smartphones earlier this month. And now they've launched it for iOS as well. So this is a free app you can download from the App Store or Google Play. And unlike the ChatGPT app, which needs you to pay US $20 a month to access ChatGPT-4, the GPT-4 engine, the 3.5 engine is free, but the GPT-4 engine costs money. Well, with these Copilot apps, you can get GPT-4 free of charge. You can talk to it, it can talk back to you. It's like having a Google search engine that just feeds you the correct information rather than you having to trawl through a list of results. And of course, Microsoft has competitors with Google, who has Bard. There's plenty of other competitors out there, and ChatGPT itself will presumably at some point launch ChatGPT-5, which will, take its time to get over to Microsoft.
And GTP5, I take it, will be Skynet at its full. No? Okay. Samsung are releasing new phones.
Yes, I've just announced that on January 16th in the US in San Jose, they'll be launching the Galaxy S24 range. So there'll be S24, the S24 Plus, and of course the S24 Ultra. They will have a titanium version, which is similar to iPhone 15's titanium. But the big thing is AI. I mean, AI is inescapable. It's got the Snapdragon Gen 3 chip from Qualcomm inside, which has got a built-in supercharged AI engine. And Samsung is promising major advances for using AI on your phone. So we'll see what they announce, but it's expected to be massive.
And speaking of massive, your new show is starting on TNT. Tell me.
Yeah, TNTradio.live on Saturday, the 20th of July, Australian time frame. My new show will start between 6 and 7 p.m. There'll be a technology program called Talking Tech with Alex. And this is in addition to the weekly segment that I do with Chris Smith on Wednesdays between 4:30 and 5 p.m. And that'll be in addition to the shows that I do with you and all the other different radio programs that I do. But if you want to see me on television, you'll be able to watch via YouTube on your TV, via Rumble, on your phone, on your tablet, on your computer. It's a global network, and I'm really excited to be starting this new show.
And speaking of excitement, you're about to head off to CES.
So CES is the Consumer Electronics Show. It's over 50 years old. There'll be 140,000 attendees from around the world, over 4,000 exhibitors. It takes over Las Vegas. It is huge. And this year, the theme will be AI. I mean, look, there'll be home automation, there'll be robots, there'll be cars that can change their paint color, there'll be, cooking automation that there was some sort of wok that can cook everything for you by itself and chop it all up. There'll be all sorts of amazing stuff. I'll have videos every single day of the best stuff that I've found at CES, but it'll be on all the different news programs. I'm very excited to be going to CES and looking forward to just seeing all the cool things that are in store for us in 2024.
That's Alex Zaharov-Royd from TechAdvice.live. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime is also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.